Before a tire can grip the asphalt, its journey begins in the silent mist of the rubber plantation.
A precise incision releases the lifeblood of the tree, pure liquid rubber latex.
Drop by drop, millions of trees contribute to the massive global demand for natural rubber. Collection is a race against time before the tropical heat begins to naturally cure the raw rubber. Every ounce is filtered and secured, ensuring the purity of the natural rubber. The morning's yield is immediately transported from the field to the initial processing center. Yields are meticulously tracked, measuring the liquid rubber before the chemical transformation begins. To solidify the liquid, a precise measure of acid is introduced, triggering a rapid chemical reaction. The acid binds the rubber particles together, coagulating the latex into a dense, spongy mass. The solid raw rubber is portioned, ready to be crushed and washed in the first stage of heavy mechanical processing. Heavy steel rollers crush out the moisture, flattening the coagulated blocks into thin, continuous sheets. Intense heat removes the final traces of water, stabilizing the natural rubber for long-term storations. The dried rubber is compacted into dense, standardized bales. The global currency, sealed and secured, thousands of pounds of natural rubber are prepared for the long journey ahead. From the remote plantation, the raw material begins its migration to the industrial manufacturing centers. Tons of raw rubber travel across continents to feed the massive appetite of the global automotive industry. The destination is a mega factory, a sprawling complex dedicated to heavy-duty gear. Arrival at the manufacturing plant marks the end of the harvest and the beginning of industrial transformation. Every kilogram of natural rubber is accounted for before it enters the complex production ecosystem. The raw material is handed over to the factory logistics team, ready to be unloaded and sorted. This sprawling industrial ecosystem is designed for one singular purpose: the mass production of the modern tire. Thousands of tons of natural rubber are stockpiled, waiting to be blended into highly engineered compounds. Strict inventory rotation ensures that older natural rubber is processed first, maintaining chemical consistency. When the production line calls, the raw rubber leaves the silence of storage and enters the violence of the factory floor. Here, human labor and heavy machinery intersect to break down the raw materials for chemical blending. The densely packed bales must be physically separated and inspected before they can be chemically processed. Even at this massive scale, the human eye is critical for spotting contaminants that could weaken a high-speed tire. To be mixed efficiently, the solid 35-kilogram blocks must be violently sliced into smaller. Immense hydraulic pressure slices the tough natural rubber as easily as a knife through butter. The sliced raw rubber is transported high above the factory floor, staging for the critical chemical blending process. Natural rubber provides the grip and elasticity, but it cannot survive the road alone. It needs reinforcement. Carbon black, an engineered nanoparticle, is pneumatically pumped from exterior silos to reinforce the tire's structure. The fine black powder is measured with absolute precision, contained within sealed vacuums to prevent severe. Sulfur and zinc oxide are precisely measured by hand. These vital chemicals will trigger the final curing process. Rubber, carbon black, and reactive chemicals converge, creating a highly engineered, unmeets. The ingredients are violently shoved into the heavy internal mixing chamber, sealed tightly by a massix. Inside, giant steel rotors grind the materials under immense pressure, generating friction so intense the machine shearing forces tear the rubber molecules apart, violently forcing the carbon black and chemicals into the matrix. The violent fusion is complete. The molten master batch drops from the chamber, radiating intense friction heat. The shapeless, boiling mass is immediately crushed by heavy milling rollers, forcing it into a continuous. Skilled operators manually cross-blend the hot rubber on the open mill, ensuring absolute uniformity in the volatile. Coated in a soapy anti-tack solution, the sticky compound is prepped for a massive cooling cycle. Hung in massive loops, the compound is blasted with powerful fans, rapidly dropping the core temperature to stop early curing. Cooled and stabilized, the master batch compound is wound into heavy rolls, ready for specialized extrusion. The cooled compound is forcefully fed into a high-pressure extruder, remelting the rubber for precision shaping. Immense pressure forces the compound through a precision steel die, forming the exact profile of the final tire tread. Rapid water cooling forces the extruded tread to shrink and lock into its exact, engineered dimensional tire. Automated blades sever the continuous tread into exact lengths, each perfectly angled piece destined to be flukeless. The precision-cut treads are layered between canvas sheets, preserving their shape and preventing them from fitterus. All the individually processed components converge at the assembly line, ready to be physically constructed into. Construction begins from the inside out, starting with an airtight, perfectly sealed inner liner. Layers of fabric-reinforced rubber are forcefully stitched together, forming the flexible skeleton of the tire. High-tensile steel bead rings are locked into position, ensuring the final tire will perfectly grip the metal wheel rim. Pneumatic bladders violently wrap the raw rubber around the steel beads, securing the tire's foundational structure. A cross-hatched matrix of steel cables is laid down, creating an impenetrable armor beneath the driving surface. The thick, extruded tread is perfectly aligned, completing the final layer of the complex chemical sandwich. Immense mechanical pressure forces out trapped air, unifying the raw components into a soft, uncured, delicate and soft. The completely assembled but uncured tire begins its journey to the vulcanization presses. Suspended high above the factory floor, thousands of raw tires await their violent transformation. Automated optical systems sort the green tires by exact specification, directing them to their dedicated curing stations. Robotic gantry systems take control, handling the delicate raw tires with perfect mechanical precision. Coated in a chemical release agent, the sticky raw rubber is prepped to enter the extreme heat of the molds. The tire enters the most extreme environment in the factory, the high-pressure vulcanization aisles. Machined from solid steel, the mold holds the negative impression of the tire's final, engineered tread pattern. The soft, featureless rubber is precisely seated into the intense heat of the open steel cavity. Tons of steel lock the tire inside, preparing it for the violent injection of high-pressure steam. Superheated steam inflates the internal bladder, forcing the melting rubber into the steel tread matrix under immense pressure. Trapped in the heat, sulfur molecules violently bond the rubber polymers, permanently transforming the soft cos. The violent chemical reaction is complete, the pressure is released, and the mold is finally opened. Through extreme heat and pressure, the smooth raw rubber is permanently forged into a fully formed automobile tire. Extracted from the mold, the newly formed tire is intensely hot and still structurally vulnerable. To prevent internal warping, the hot tire is rapidly inflated and spun, locking the steel belts into their permanent chorda. A slow, continuous journey through ambient air ensures the deep core temperature drops evenly, finalizing razor blades strip away the mold artifacts, leaving the deep tread pattern perfectly clean and aggressively sharp. Despite the massive automation, the human eye remains the ultimate judge for surface imperfections and structural integrity. Spun at highway speeds, sensitive computers analyze the mass distribution, ensuring the heavy rubber will repairs. Crushed against a steel drum under immense load, sensors verify the internal stiffness and structuralness. High-voltage X-rays peer completely through the thick rubber, exposing the internal steel matrix to artificial. Passed by both human and machine, the flawless tire receives its final branding and specification label. The completed, indestructible rings of steel and rubber are meticulously stacked, ready to be deployed to the court. To guarantee the safety of millions of drivers, perfectly good tires are randomly pulled from the line to be systems. A diamond-tipped blade bisects the finished product, violently exposing the hidden, highly engineered under intense magnification. The flawless fusion of steel armor and chemically bonded rubber is verified down to the millimeter. Subjected to relentless mechanical stretching, the cured rubber proves its immense resistance to tearing and physicris. A blunt steel spike simulates extreme road hazards, measuring the exact force required to violently breach an. Spun far beyond intended limits, the tire battles immense centrifugal forces that threaten to literally tear the X. Internal friction generates extreme heat. Thermal imaging ensures the engineered compound will not melt. Advanced friction rigs simulate wet asphalt, physically proving the chemical compound's ability to grip the road and finesse. Laser topography analyzes microscopic abrasion, feeding crucial wear data back to the chemists, to Croverseeks. Only after surviving the most brutal physical punishment is the mass-produced batch certified. With chemical and structural integrity verified, the massive batches are instantly cleared for global distribution. The completed products enter a cavernous logistics hub, a highly organized ecosystem holding millions of robotic cranes manage the vast inventory, maximizing vertical space and eliminating human error in storage. Complex algorithms pull exact batches from the grid, perfectly matching physical inventory to real-time global demand. Secured inside corrugated steel armor, the heavy product is prepped to survive the brutal forces of Intrepis. Sealed with a serialized lock, the container becomes a secure vault, protecting the engineered rubber on its globe. Heavy diesel machinery takes over, pulling the massive payloads away from the factory floor and into the transport grid. An endless river of steel and rubber flows outward, supplying the global arteries of transportation. And this is how modern factories produce automobile tires from start to finish.
Subscribe for more real factory breakdowns.